Volumes of pyramids and cones. Our objectives: find the volume of a pyramid and find the volume of a cone. So our definition for volume of a pyramid, it's 1/3 the volume of a prism. You'll remember volume of a prism was base area, times height. So volume of a pyramid is 1/3 base area times height. Remember, when we were working with pyramids before and finding the surface area, we had to work with what was called the slant height, or L. We don't use that for volume. We use the regular height, which is that perpendicular line drawn between the vertex and the base. So that's what we need for finding our volume. Example 1. The entrance to the Louvre Museum in Paris, France, is a pyramid with a square base and a height of 21.64 meters. What is the volume, approximate volume of the Louvre pyramid? Here's a little picture right here. It shows you right here that one side of the base is 35.4 meters. So to find our base area, it's a square base, so we know its area is side squared. So 35.4 meters squared. 0.4 squared is 1253.16 meters squared. So to find our volume, formula is 1/3 base area, 1253.16, times the height, which we were told was 21.64 meters. So 1/3 times 1253.16 times 21.64 is 9,039.46. 9039.46 meters cubed. So remember, since we're working with volume, all of our units are going to be cubed. So there is your volume. Example 2. Find the volume of the square pyramid below. Round your answer to the nearest tenth. All right, so again, we've got ourselves a square base. So our base area is side length squared, so 10 inches squared, which is 100 square inches. So our volume, 1/3 base area, times the height, which is 9 inches. So 1/3 times 100 times 9, we get 300. So our volume is 300 inches cubed. Easy peasy. Example 3 adds a step. What's the volume in cubic feet of a square pyramid with base edges 40 feet and slant height 25 feet? So this time it gives us our slant height, and we have to calculate the height of our pyramid. So if we look at a cross section of our pyramid, so say this is a cross section of our pyramid. Our base is 40, so our height is going to go halfway between, so that part's 20. And we know the slant height is 25, so that's our hypotenuse. And so again, since we've got a right triangle, we can use Pythagorean theorem to figure out what our height is. So that's going to set up the equation 20 squared plus h squared equals 25 squared. So that's 400. That's 625. Subtract 400 on each side. So h squared is 225. Square root to get h by itself. I believe that's 15, but let me double check. Square root of 225 is 15. So our height of our pyramid is 15 feet. All right, and then it was a square pyramid again, so our base area is going to be side length squared. So 40 squared is 1600. All right, so our volume, now that we've got our height, is 1/3 base area times height. So we've got 1/3 times 1,600 times 15. So 1/3 times 1,600 times 15. And we get 8,000. So the volume of our pyramid is 8,000 feet cubed. Example 4. Find the volume of the given pyramid given its slant height. Round to the nearest tenth. Alright, so we're going to have to do the same thing we did on the last one, where we use Pythagorean theorem to figure out our missing side. So we know if this is 11 feet, then half of that is 5.5. So the base of our triangle is 5.5. So to find our height, h, we're going to do h squared plus 5.5 squared, and that it has to equal our hypotenuse, which is 15 squared. So let's see, 5.5 squared is 30.25. So we've got h squared plus 30.25 equals 225. Alright, so minus 30.25 on each side. So h squared equals, let's see, 194.75. And then we're going to take the square root of each side to get our height. So let's see, square root of 194.75, 13.95. So it wants around to the nearest tenth. So that would be, let's see, that would round that up, which would round up to 14. So 14, approximately 14.0. All right, and then again, we've got our square base. So our base area is going to be side squared. And 11 squared is 121. So the volume of our pyramid, 1/3 times base area times height. So 1/3 times base area times height. 564.7 feet cubed is our approximate volume. All right, volume of a cone. So the volume of a cone is 1/3 the volume of a cylinder. If you remember from the other day, the volume of our cylinder was base area times height, or pi r squared h. So the volume of a cone is going to be 1/3 base area times height, or 1/3 pi r squared h. Where b is the area of the circle base, so b is pi r squared, and h is the height of the cone. All right. there's volume of a cone. So example 5, find the volume of the cone, round the volume to the nearest tenth. Nearest whole number. So we've got our circle base has a radius of 3. The height of our cone is 14 centimeters. So volume 1/3 pi r squared h. So 1/3 times 3 squared times 14 is 42. So 42 pi would be our exact solution if that's what it wanted. But it wants an approximation rounded to the nearest whole number. So let's do 42 pi is approximately 131.9, so to the nearest whole number would be 132. So our volume is approximately 132 centimeters cubed. Example 6. The covering on a teepee rests on poles that come together like concurrent lines. The resulting structure approximates a cone. If the teepee pictured is 12 feet high with a base diameter of 14, what is the approximate volume? So we're told the height of our cylinder is 12 feet. We're also told the diameter is 14 feet, so that means the radius is going to be 7 feet. Plug that into your formula. Volume is 1/3 pi r squared h. So 1/3 pi times 7 squared times 12. 1/3 times 7 squared times 12 is 196. So our exact solution in terms of pi would be 196 pi feet cubed. No, that's our exact solution, so no wigglies. Equal sign. All right, so our approximate volume, 196 pi, is approximately 615.75. So 615.75 feet cubed is our approximate volume. Example 7. What is the volume of the oblique cone below? Oblique cone below. Give your answer in terms of pi and also rounded to the nearest cubic foot. So just like yesterday, thanks to Cavalieri's principle, we can find the volume of our figures regardless of whether they're right figures or oblique. Just as long as the cross-sectional areas would be the same at all levels, then the volume's the same. So we don't need any special formula for this one, just the one we've been using. You'll notice we're given that the base here is 30 feet, so our radius is going to be 15 feet. And the height of our pyramid is, our cone is given as 25 feet. So volume is 1/3 pi r squared h. So volume is 1/3 pi times 15 feet squared times 25 feet. So let's see, we've got 1/3 times 15 squared times 25. All right, so 1,875 pi is our exact solution, which it asks for. And then it also wants an approximation rounded to the nearest cubic foot. So 1875 pi is approximately 5,890.848. So that's going to be, we're going to have to round it down. So 5,890 feet cubed would be the nearest cubic foot. Example 8. What is the volume of the oblique cone below? Give your answer in terms of pi, also round to the nearest cubic foot. Alright, so this time we've got our height right here is 12 meters. Our radius is 6 meters given to us in our picture. So just plug it on in. 1/3 pi r squared h. So 1/3 pi times 6 meters squared times 12 meters. So 1/3 times 6 squared times 12. 144 pi meters cubed is our exact solution. And our approximation to the nearest foot. So we're going to have to round down again. So our volume is approximately 452 meters cubed. Alright, so the last two examples are like some of the ones in the homework, so I wanted to kind of go over some of them with you. So this one here says to find the volume of the pyramid rounded to the nearest whole number, and you'll notice it's giving you a whole bunch of information that you don't necessarily need. So let me zoom in on that a little bit so we can see what we're given. So we've got here, we're told the slant height is 3.2 meters. The lateral edge right here is 3.8 meters. The altitude, 2.5 meters. Base side is 4 meters. And we're told this angle right here is 51 degrees. So we know if we're looking for volume of a pyramid, it's 1/3 base area times height. So base area, all we need for that is this area here, 4 meters squared, because it's a square base. So 16 meters squared is our base area. And then we need the height, which is the length of the altitude. Our altitude's right here, so our height is 2.5 inches. Or 2.5 meters, sorry. So h is 2.5 meters. So plug that into your formula. 1/3, 16 meters squared, 2.5 meters. To the nearest whole number. Okay, so we've got 1/3 times 16 times 2.5. So to the nearest whole number, that's going to be 13. So 13 meters cubed. And we'll actually, that should be approximately equal to. So that's all that one is asking for. There's no special thing you got to do except identify what of the given information you're given, or what of the given information you need, because we're given way more than we need. Okay, so the last example, we've got ourselves a composite solid. It's got a square base, so our the bottom part, this part of the solid is a prism, and then it's got a top that's a pyramid. So we're going to find the volume of both parts, add them together. So let's start. Let's see. Let's find the base, or let's find the volume of the rectangular part. Actually, it's a square because we got 24 on each side. All right, so the volume of the, gosh, I'll just say B, volume for the base. It's going to be length times width, and the height of our prism here is 15 feet. So 24 times 24, because it's side squared, So 24 times 24 times, not divided by times, 15 is 8,640. 8,640 feet squared. Oh, cubed, sorry, volume cubed. Alright, then for our pyramid, I'll put P for pyramid. So the volume of our pyramid is 1/3 base area, which again is going to be 24 feet times 24 feet. And the height of our pyramid is 9 feet. So times 9 feet. 9 feet. So 1/3 times 24 times 24 times 9 is 1728 feet cubed. So the total volume is going to be those added together. So 8,640 feet cubed plus 1,728 feet cubed is 10,368 feet cubed. And there's the volume of the composite solid. All right, so remember, this is our last week of instruction. I'll still have office hours Tuesday through Friday, 9:30 a.m. to 10. And you can email me or snap me if you got questions. Have a good day.